Planet Earth might also be called planet water. 70% of its surface is covered by water. Water seems to be almost everywhere. At any given time, about 2 to 3% of the atmosphere is water vapor, an amount equal to an average depth of 2.5 centimeters of water. Each year, about 50 times that amount, or an average of a meter of water, drops to the earth as rain and snow. Water often seems to be everywhere, all around us, in the oceans, lakes, streams, glaciers, even in the human body. Our bodies contain about 65 to 70% water by weight, and with so much water around us, it would seem that water scarcity would seldom be a problem. And we could just take that abundance of water for granted. Indeed, many of us tend to do just that, assuming that inexpensive water will magically appear whenever we turn on the tap. But, for several reasons, water scarcity is likely to be one of the world's most significant issues of the 21st century. First, water is very unevenly distributed over the Earth's land surface. Some areas have plenty of water, but some have hardly any. In many of the Earth's deserts, human habitation is made nearly impossible by the lack of water. But each year, more people seem to make their living in these areas of perennial water scarcity. Second, not only does water vary unevenly in space, but also in time. Rain generally comes in dependable patterns, but at any given time, large areas of the earth are affected by droughts that may last anywhere from a few weeks to a few years. On the other hand, each year floods cause greater loss of life and property than any other single natural disaster, illustrating another consequence of the uneven distribution of water. Third, the amount of fresh water easily available for human use is extremely limited in comparison to the amount of water on the planet Earth. 97.5% of the Earth's water is in oceans or other salty water bodies, and is unfit to drink without expensive desalination. Of the remaining 2.5% of water that is fresh, 68.6% is frozen in ice caps and glaciers, and 30% is in underground aquifers, some of which are much too deep to easily tap. This leaves about 1.3% of the fresh water, or about 0.03% of all of the Earth's water, that is easily available to us as fresh water in rivers, lakes, wetlands, the atmosphere, seasonal snowpack, soil, and the biosphere. Since humans and all other organisms need fresh water nearly every day to survive and to make a living, we often find ourselves in competition for a scarce and precious resource. Add in the effects of trends such as growing population, rising standards of living, increasing pollution, and the potential effects of climate change, and the problems of water scarcity for many people become serious indeed. According to the United Nations, 1.2 billion people currently live in regions of physical water scarcity, meaning they average less than 1,000 cubic meters of renewable water resource per person. By the year 2025, 1.8 billion people are expected to live in regions of absolute water scarcity, meaning they will average less than 500 cubic meters per person of renewable water resources. Scarcity, floods, conflicts, pollution, these are just some of the factors that are likely to bring water issues to center stage during the rest of this century. UN Secretary General Ban Ki-moon puts it this way: shortages of water contribute to poverty. They cause social hardship and impede development. They create tensions in conflict-prone regions. Too often, where we need water, we find guns. There is still enough water for all of us, but only so long as we keep it clean, use it more wisely, and share it fairly.
All right, well, hello, I'm Reagan Wascom, the chair of the Water Center at Colorado State University, and it's my pleasure to welcome you to this course on water, civilization, and nature, addressing water challenges of the 21st century. So water's been a central focus of Colorado State University since we opened our doors in 1879. It was here that Elwood Mead, the namesake of Lake Mead, established a program in irrigation science to provide a scientific basis for growing food in semi-arid lands. And Ralph Parshall invented the Parshall flume for accurate measurement of water flow. Today, CSU has graduates working on water projects on every continent on the globe. 120 faculty members address water issues in departments as diverse as liberal arts, engineering, agriculture, natural sciences, vet medicine, as well as the humanities. So during this course, you'll have an opportunity to explore a wide range of pressing challenges related to water. You'll learn about innovative approaches to addressing these challenges, and you'll see how issues affect both the larger world as well as yourselves as individuals. Each topic will be addressed by a different member of CSU's multidisciplinary water faculty in one or more lectures of about 20 minutes in duration. The lectures will cover topics as diverse as water disasters, water conflicts, meeting the needs of ecosystems as well as humans, aquatic life, the effects of climate change, as well as water pollution, governance of water, and water for food production. You'll also find suggestions for readings, links to interesting websites, questions for discussions, links to other CSU resources related to the topic, and among those you'll find websites, other online courses, as well as certificate programs and academic programs. There'll be opportunities to connect with students who share your interests and whose characteristics are similar to and very different from your own, and interact with them and the course instructors. The modules in the course generally stand alone, so you'll be able to take them in any order that interests you. Thanks for embarking on this course. We hope you enjoy it.